This is the second part of our chapter. We're going to talk about the reactivity of acids and bases. When acid and the base solution, when they are allowed to react with each other, they produce salt and water. This is called as the neutralization reaction. Mostly we define neutralization reaction as the reaction between an acid and base. In fact, the true form of neutralization is the combination of hydrogen plus 1 plus hydroxide minus 1, and they combine to give one water molecule. This is the net ionic equation for neutralization. Now, in the table you have been given some acid and bases. First, we're going to classify them as strong or weak. For example, hydrogen nitrate, this is a strong one. Hydrogen sulfate, this is strong. Now the acid written on parentheses here, this one, as you see, this has one less oxygen than the first one, then it is going to be a weak one. Next one, hydrogen phosphate, weak acid. And this one, hydrogen perchlorate, is a strong one, but as the number of oxygen atoms decreases, the acidity strength of these substances decreases also. So these are all weak acids. This is carbonic acid, the acid that you probably drink when you drink Coke or soda. This is a weak one. Acetic acid, known as the vinegar acid, as you know, is the weak one. And this one, the compounds formed between the halogens and the hydrogens. The three of them are strong: hydrogen chloride, hydrogen bromide, and hydrogen iodide. This one is the weak one. Now comes the sodium hydroxide. If you have a compound formed from one alkali metal and a hydroxide ion, probably it's going to be a strong base. So this is sodium hydroxide, a strong one. Next one, potassium hydroxide, also strong. Lithium hydroxide, also strong. And the rest of it, these three of them, the compounds formed with an earth alkali metal and hydroxide. Calcium hydroxide is also strong. Barium hydroxide is also strong. But this magnesium hydroxide is a weak one. And now comes the ammonia. Ammonia's aqueous solution produces weak basic solution. Now what about their names? The first one is hydrogen nitrate. The second one is hydrogen sulfate, known as the oil of vitriol. And phosphoric acid. Hydrogen perchlorate. This is carbonic acid. This is acetic acid. You can also write as vinegar acid. And you just read all these acids formed between hydrogen and halogen, like the first one, hydrochloric acid. Now, what about the bases? Now, the bases have also some special names. For example, the first one known as the caustic soda. The second one is potash caustic. This has not a special name, but is known as lithium hydroxide. This is calcium hydroxide, but this is known as the slaked lime. Magnesium hydroxide is known as milk of magnesia. And barium hydroxide, just barium hydroxide. And we have already told this NH3, it's known as ammonia. Now we can also talk about the reactions formed between the acid and bases and with the metals. If you have an active metal, now what is the meaning of an active metal? An active metal can give its electron really easy. So when it gives electron easy. It is going to be reacted with some acids. It doesn't matter whether this is strong or weak. For example, the first one, potassium and hydrogen chloride. When they reacted, they give potassium chloride as the salt and 1/2 hydrogen gas. When you just like to balance it, you're going to see that this is already balanced. Next one, magnesium is in the group of 2A, so it has the oxidation number of 2+, so it produces the salt magnesium chloride and again plus hydrogen gas. So how can you summarize it? You can say that if you have an active metal, when it's reacted with the acid, it produces a salt and hydrogen gas. So this is a kind of displacement reaction. Zinc is in the group of B's here, 2B. So this always has the charge of 2+. So when they are reacted, they produce zinc nitrate plus hydrogen. And sodium is in the group of 1A. Again, it produces sodium sulfate plus hydrogen gas. And now comes the last one. This phosphoric acid is a triprotic acid, just remember. So it produces sodium phosphate plus 3/2 hydrogen gas. So we have forgotten to balance this D and E. You have to put 2 in front of sodium and you have to put 3 in front of this sodium. The given metals are active metals. So they release out hydrogen gas when they react with the acids. On the other hand, there are also noble metals, like noble gases, which are resistant against oxidation and corrosion. So gold and platinum, these are the most important noble metals. They only react with aqua regia, which is composed of hydrogen nitrate and hydrochloric acid, 2 strong acids. And copper, mercury, and silver, these are like half noble metals. They only react with the strong acids containing oxygen atom. For example, if I ask you whether if copper reacts with hydrogen chloride, you're going to tell me no, because it doesn't contain an oxygen atom, even though it's a strong one. Or if there is mercury here, does it react with the nitric acid? Yes, this is a strong acid containing oxygen atom. If you have gold and you reacted with the sodium hydroxide, gold needs only aqua regia, so there is no reaction here. So what else do we have? We have active metals, as we have said already. What kind of metals are those? They can be the metals in 1A, 2A. And amphoteric metals, they are also active metals. What else? You have amphoteric metals. You have zinc here, lead here, chromium, tin, beryllium, and aluminum. Amphoteric means they can give reaction both with the acids and bases, no matter whether they are strong or weak. What do we have? We have noble metals. Noble metals are gold, platinum. These are the ones that are the most noble. And you have least noble like copper, mercury, and silver. Now the most noble ones, gold and platinum, they can only give reaction with the aqua regia. Remember, it was synthesized by Jabir bin Hayyan. And these are, let's say, half noble metals. They can only give reaction with the acids, strong acids containing oxygen atom. It can be hydrogen sulfate, hydrogen perchlorate, or nitric acid. Now, what do we have more? We have acidic oxides. These oxides are non-metal oxides, like sulfur dioxide, carbon dioxide, dinitrogen pentoxide. Now, meaning when you put them in water, they are going to be reacted with the water molecule and produce an acid. For example, if you have sulfur dioxide, when you just put it in water, it produces the sulfurous acid. Or carbon dioxide, when you put it in water, it produces carbonic acid. And diazote pentoxide, when you put it in water, it produces the nitric acid, very strong one. So these are called anacidic oxides. Now what else do we have? We have basic oxides. These are going to be usually metal oxides, like sodium oxide, potassium oxide, calcium oxide. So this is going to be just as same as the acidic oxides. When you put them in water, they're going to be reacted with the water and produce some base. For example, sodium oxide plus water, it will give you 2 sodium hydroxide solutions. So calcium oxide, when you put it in water, remember this was lime, and when you just react with the water, it's going to be slaked lime, which is calcium hydroxide. What else do we have? We have, of course, amphoteric oxides. Now, all the metals that are amphoteric also produces amphoteric oxides, like tin 2 oxide or beryllium oxide or chromine 3 oxides. And finally, we have neutral oxides. You have only 3 of them. This is going to be carbon monoxide, nitrogen monoxide, and dinitrogen monoxide.